Went good.
Uh, you were quite dicey about what's gonna happen, right?
So I'm like that
Yes,
from for, for all the exams.
for all but it went fine, right? So if it ends good, then it's good. And good evening, Mariam.
Good evening, sir.
How are you?
I'm good, sir. How are you?
I'm also fine. And also, how was the examination? I'm audible in a good way, right? There is no lag and stuff.
No,
Yes.
sir.
Mariam, how was your examination?
Yes, sir. My exam was good.
Your exam was good. The results are out.
Yeah.
Okay, so expected or better than expected? How's it?
I just got 82%.
Okay, fine. That's congratulations. Okay, now Sania and Amalia, these two are new. So can I have your branch, I would guess? PCB or PCM? Sania? I'm audible, right? Sania?
Yes, sir. Can you repeat again, sir?
Okay, fine. Do you have physics, chemistry, biology, or physics, chemistry, maths, or biology and maths both?
I have physics, chemistry, and biology.
You have PCB. And Amalia, if I am pronouncing it right,
Yes, sir.
okay, what do you have, PCB or PCM?
PCM.
PCM, okay, fine. PCM. Okay. So PCB, PCM, but still you're in 12th standard. That means you have done physics a lot. That means differentiation and integration, quite differentiation, and some integration would not give you some headaches, I guess, right? You are introduced to differentiation and integration.
Yes, sir.
Yes, sir.
About Ahmed and Mariam, I know. Okay, fine. Others also. Now we are going to start with chapter 1, that is solid state. Okay, and I guess your school does not do that thing of starting with organic chemistry. They start with solid state, right?
Sir, they started Unit 2 solution.
Okay, they started unit 2 solution. Okay, so is solid state not there in your syllabus or what?
Teacher said that last year it was not deleted, but before that it was deleted, so they did not start the chapter yet.
Okay, so they did not start the chapter yet. Fine. That means we have to start with chapter 2, that is solution, correct?
Yes.
Yes, sir.
Yes, sir.
Okay, fine. So solution. Now, why do we, first of all, you have a solid state. So solid state chapter has its own importance because the most of the things that you see around yourself, these are in solid state. Like even the phone that you are using has around 3 elements in it, and all of them are solid state. But why solutions? Why do you think why we need to study solution?
Pair of component. Mixture of elements.
I guess yes. A bio student can give some more insight, I guess, in this. Biology student, most of the biological systems in our body are in liquid state, right? They are in aqueous medium, correct?
Yes.
Yes, sir.
And many of the medicines that you take, they are also in liquid state. The syrups and all, they come in liquid state, right? Now, another thing that comes in liquid are the paints. Paints are in liquid state. Then you have the oil industry. The whole oil industry is in liquid state. Then what do you have? What else do you have in liquid state?
There is a lot.
There is?
There is a lot. We'll
There is
mention
a
on.
lot.
Yes, sir.
Yeah, there is a lot. And another thing that is very important is that the water that we drink, right? The water that we drink, it is in liquid state.
Yes.
It is in
Yes, sir.
liquid state. But if that water gets contaminated, we have to study the liquid properties of the water and then understand how hard it is. And I mean, what are the components in that and how harmful they are. Okay, fine. So we will start first of all with concentration terms in liquid state. Okay. Concentration terms. What does concentration terms mean? For example, if you are having some medicine, that particular syrup is not whole medicine. It's not medicine all in all. There are some components in the syrup which is medicine and some components which are just some solvent, So we have a mixture there, right? We have a mixture there. So if we have a mixture, then we will have at least 2 or more components. If we have a mixture, let me share the screen now. If we have a mixture, we will be having 2 or more. If there is a mixture, we will be having 2 or more components. Mixture. What is a mixture? There will be component 1 and there will be component 2. Now, I take the example of Ruh Afza because I like it. You all know what is Ruh Afza, right?
Yes, sir.
Yes, sir.
Like Ramzan is near corner, the market would be stocked with Ruh Afzas. So Ruh Afza, in Ruh Afza, what do you have? You have either Ruh Afza or you have, and the other component is water,
Water.
right? And some people go out of their way and add more sugar, but I like Ruh Afza and water just that. Okay, you can add sugar also. Then also this will be a mixture, correct?
Some add milk as
Now,
well.
now you tell me, which of the components, Ruh Afza or water, which is in larger amount?
Water.
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 This is in larger amount. Larger amount. And what is Ruh Afza is in smaller amount. It is in smaller amount. Larger amount and smaller amount. Now we give this a name. We give this a name. Like you will not say every time, like if you are having either Ruh Afza or Rasna or some other kind of sharbat, you will not say like add this in smaller amount and add that in larger amount. Then you get a sense. Now, if you get a sense, what you do, you give it a generalized name. Whatever in a mixture is in larger amount, we call that a solvent,
Solvent.
right? If any component of a mixture which is in larger amount is known as solvent, and the component which is in smaller amount is known as
Solute.
solute, right? It is known as solute. Now, if we mix them together, then what do we have? Solution.
Solution.
We have solution, right? We have a solution. Now, solution, it is another term for that is, let me make glass of Ruh Afza here, I guess. Right now, here what I can say is that the majority of the portion is water and the minority of the portion is solute. I should write solute like this, and here solvent to generalize it. Solvent. Now you remember, you also make this in this way, that a curly bracket representing solvent and an arrow representing solute. That will make you remember that larger amount is for solvent and smaller amount is for solute, and you give a curly arrow like this, sorry, curly bracket like this, and you name it this solution. Okay. Now this mixture is homogeneous mixture. It's mixture of 2 or more components, 2 or more components, right? So solution, what is a solution? The first definition, my chapter has started, solution. The name of the chapter is solutions. What is the definition of solution? A homogeneous mixture of 2 or more components. A homogeneous mixture of 2 or more components, right? Now, what does this homogeneous mean? It means that whether you dip a spoon in this glass of ruh afza and you take out a spoon of ruh afza from the upper portion of this solution, or from the downward portion, it would taste the same if it had been mixed well enough, right? Because there are some horrible people which they don't mix and the whole ruh afza is sitting in the bottom. So don't make ruh afzas like that, okay? The whole ruh afza is sitting. No, we want a homogeneous mixture. What kind of mixture?
Homogeneous.
Homogeneous mixture. Okay. Now this is a solution, a homogeneous mixture of 2 or more component. Okay. Now you can copy this. Solutions. Present in larger amount. Solute present in lesser amount.
So what if the solute and solvent are in equal amount?
If the solute and solvent are in equal amount, then the component which decides the phase of the system will be regarded as the solvent. Solvent is the one which determines the phase. Right about the physical state of the solution. Physical state of the solution. Okay. Done copying this down. No, yes, anything?
Yes, sir.
Yes, sir, done.
Done copying this down. What about done? Okay, fine. Now you can have different type of solutions. If you have a gas, now the name of the solution, if I say a liquid solution, that means the solvent is of liquid state. If I say a gaseous solution, that means the whole system, the solution in that the solvent is gas. So by that I can divide it in some major portion like this. If I have, for example, if I have gas solutions, if I have gaseous solution, I have gaseous solution. What happens here? I can make the gaseous solution either by having a solvent. The solvent here would be always gas, But what will be the solute? What will be the solute here? The solute can be 3. What can be the solute? Solute can be either gas, liquid, or solid.
Solid.
Solute, oh, sorry. Change of color. Solute can be either gas. They can, okay, not gas like this, gas, liquid, or solid. Gas, liquid, or solid. Okay. Now, but can you give me an example of gas solution where the solvent is also a gas and the solution
Air.
Mixture of oxygen
Carbon
and
dioxide.
oxygen and
Carbon dioxide.
nitrogen.
oxygen and nitrogen. Okay, something, I mean, like the atmosphere, right?
Nitrogen.
It has both, or it has nitrogen, oxygen, and carbon dioxide mainly. There are some water vapors also. So for example, I can have Example, I can have H2 plus N2. Okay, sorry, not this color. H2 plus N2. An atmosphere is also a good example. Atmosphere. Okay. Now, any example of gas plus liquid?
Soda water.
Carbonated drinks, yeah.
Yeah, that is gas plus liquid, and is that a gaseous solution?
No.
Gases.
It's not gaseous solution. It is a liquid solution, right? Because the physical phase that is determined by what? It is determined by.
Liquid.
It is determined by
The solute.
the solvent. The physical state is determined by solvent, correct? So now there is one example which is of chloroform. It is mixed with nitrogen. Now chloroform is a liquid. Chloroform plus nitrogen. It's an example of gas plus liquid. Now, an example of gas plus solid would be of camphor. You know camphor?
Camphor.
Yes.
Camphor, and it is also mixed in nitrogen. Camphor in nitrogen gas. Camphor in plus nitrogen, N2. Now, you can start thinking about the other solution. What will be the other solution? Liquid, correct?
Solution.
Yes.
Now, liquid can be again made a solution by liquid gas. Then there can be liquid. Now, liquid is very easy, and liquid solid. Come up with examples now. Gas, liquid, solid. A gas is mixed with liquid. Now, what is the example? And all these solutions will be known as liquid solutions. Okay, fine. Now there are some things that I write, and you just have to understand them as the class goes. Now this is solution. Okay.
Okay, sir.
Okay,
Fine.
sir.
This is solution. You said carbonated drinks.
Yes, sir.
Carbonated drinks. And then in the aqueous the animal that fishes and all, they live in inside water, and inside water there's also oxygen, right? So O2 plus H2O liquid, and that is why they are able to breathe. Now what about liquid? Okay, fine, Ruabza.
Yes, sir.
I mean, in NCERT, I remember they have written what, ethanol. Oh God, so sorry for that. Ethanol plus H2O. You know what is this? What is ethanol plus H2O?
Alcohol plus water.
Alcohol.
Yeah. They are trying to make you drunk. Fine. Now we are writing Ruabza, not ethanol plus water. Now then we have solid.
Salt
Example for solid.
Salt
Glucose.
solution.
Salt solution, very easy. Salt solution. Salt solution. Okay. Now start. I mean, your brain should start thinking of some of the next one. We will have what solution? Solid solution, right?
Yes,
sir.
Yes, sir.
Yes, sir.
Think of those. Can you think of any?
Yes, sir.
Now, tell me.
Cement.
You have
Cement
here what?
mixed with water.
Solid, and this is solvent is solid, and this is gas. Then you will have liquid, then you will have solid. Okay, yes, the mixture of cement, that's right. That would be a solid plus liquid, correct?
Yes, sir.
Okay, now, and what about solid plus gas? I mean, obviously you won't be knowing this because these are, these are very specific solutions which are used by chemists. It is solution of H2 in palladium. Okay. Now, if you have maybe somewhere in the organic chemistry, you would have seen something like this, H2/PD. I mean, this type of symbol, it may, if it has not occurred till now to you, then you will learn this in organic chemistry of 12th standard, H2PD. Now, this is a solution of H2 gas in palladium, which acts as a catalyst. We will learn this kind of system in organic chemistry. Okay, this is called catalytic reduction. Fine. Now, as said by Ahmed, liquid solution, liquid, that is solid plus liquid. What do we have? Cement plus H2O, water, correct? And some other mixtures also, right? Other mixture. But is that homogeneous?
No.
No.
Can we put that here?
No.
No. Okay, fine. Now, so what do we have? It is amalgam solution. We say that amalgam. Now you will hear amalgam again in electrochemistry. That is the next chapter. Amalgam of, you can have amalgam of KCl in mercury, etc. But generally amalgam is made with Hg, that is mercury with some of the group 1 elements, mercury. What is group 1 element? For example, you can have with potassium, which sodium is the one which we use usually. Amalgam of mercury and sodium. Now solid solution.
Copper dissolve in gold.
Copper dissolve in gold. I mean, all of the alloys that we have, even steel is a solution, right?
Yes, sir.
Yeah, right. Steel is also a mixture of many things. So, and also it is homogeneous mixture. Now NCERT, I guess NCERT have this, right? Copper in gold. And you can have either steel also. Now we have 3 sections. This is the first section, gas plus gas. This is the second section, liquid plus liquid. This is the third section, which is solid plus solid. Now you tell me, which of these 1, 2, 3 you are most familiar with?
Liquid.
Yeah, the section 2, right?
Yes, sir.
Yes, sir.
Okay, fine. Now, what do you think which is easier to study? The things that we have already acquaintance with, that we have already seen, or the things that we have never seen of, never heard of? What is easy?
Already seen.
Already seen.
Already
So don't think that this chapter is tough. You are already learning. You will be mostly learning liquid solutions. Okay. I'm sorry. Liquid solution. I mean liquid plus gas, or liquid plus liquid, or liquid plus solid. Okay. So you're learning the easiest one of all. Okay. Now, so remember that this is easy. Now, if you have to study the solution of H2 and PD, I mean, this type of chemistry is taught in bachelor's and master's level. Okay, so you are not studying the tough ones, you are just studying the ones that you can easily see. So you are using what? The easiest one. Don't worry about that this is very tough. It is easy. Okay, now you can copy this. Now copy that. This is the easiest part also. Let me know when you are done copying. Okay. Also in the chat, if you have finished, or if you can type, just personal message me. In which subject did you get the highest marks? You scored the highest in which subject? I mean, don't say please English and all. Physics, chemistry, bio, or if you have maths, then in these 4 only. I'm not going to hear computer science, okay, or English. Within physics, chemistry, biology, or maths.
The computer is harder than bio.
Computer science? I don't think so.
Yes, sir. So it is really. Like you have to remember so many programs while you don't know anything of it.
Why you have to remember so many programs? You can logically derive those programs actually. Okay, fine. I have got an answer from Mariam. What about others?
So I have to see my report card.
Okay, you don't remember. But do you have, I mean, either this or that? No? No, I guess. Okay, fine. What about others? Amalia, Sanya, Ahmed doesn't know.
Sir, I already sent you
So it might either be
I'm sorry.
text.
I mean, who was speaking in a very soft voice? I couldn't hear that. What did you say?
Sir, I already sent in the message in the chat.
In the chat? Okay. I haven't received it. Okay, fine. It may come in a bit of time. What about Sanya?
Sir, I will check and say I don't remember.
So you don't remember. Okay. Okay, fine. Amalia, yeah, I've got yours. Maths and biology. Okay, fine. Now let me know if you're done noting this. Okay.
so done.
Okay, fine. I'm waiting for the others. I guess done.
Yes, sir.
No, sir.
Oh, okay, fine. Ahmed, did you write that you are studying the easiest part?
What, sir?
Did you write that you are studying the easiest part here? The liquid, like the liquid solutions are the easiest. Did you write this?
No, sir, I did not.
All right, that also. It is so. I mean, see, I'm a big fan of affirmations. Okay, what are affirmations? Do you know about affirmations?
Yes, sir, I guess.
What is affirmations?
Maybe simplifying things into easy and hard and trying to study in that way.
No. That is not affirmation. Affirmation is uh, uh, like you have some idea, or you have some thought, you have some stand, you have some opinion. I affirm that opinion. Okay. I mean, you have it and I affirm it. That means it will multiply in your sense. Okay, fine, that is right. So what is affirmation in a personal sense? It is that the things, the stories that you tell yourselves, it becomes the truth. And if you always say that you are good in something, you are good in something, you are good in something, then you will definitely become good at that. And also remember, I mean, I hope every country has their pledge, right? What do they do for Indians? I'm an Indian. All my brothers and sisters, etc. So this pledge, why do some schools have pledges daily, and why do any country has a pledge? It is only to affirm things, that you have to remind yourself of some things, and even like we say that in our religion also we say some things very often, that fine, I bear witness many times, only to affirm ourselves, and that particular sayings that we do, it come out as an action. So if you say that we are studying easy things, it can be done, you will be able to do it in a smooth way. I mean, it helps. So that is why I'm writing, trying to say that write easiest part. Okay, liquid solutions are easiest. I hope now you all have done.
Yes, sir.
Am I right?
Yes, sir.
Okay, now moving on to the next thing. Okay, fine. Now we have classified, now we know what we have to study. The next thing is, let us say, you have to make, do you know the recipe of Ruh Afza, Ahmed? How many spoons of Ruh Afza in how many glasses of water? Any idea? Any one of you? Can anyone make good Ruh Afza? No one.
We just drop
Okay,
it
what
like
about
that.
chai? You just drop it like that, then start tasting it. Okay, अब ठीक है,
Yeah.
अब थोड़ा सा और डाल देते हैं, अपनी पानी कम. Okay, fine. Now what about chai? I mean, in chai you have to be a bit concise, right?
Yeah.
No idea. No idea about chai?
3 cups of water, then 2 spoons of tea powder.
2 spoons. Okay, 1 cup of water plus 2 spoons of tea powder. Oh, what about milk? No milk?
Yeah, milk also.
Okay, fine. 1 cup of
1 glass.
water. Okay, so please say it loudly.
1 glass of milk.
One glass. I hope that is 1 cup of milk.
Yeah, 1 cup.
1 cup of milk. Okay, and 2 spoon of tea. 2 spoon of tea. Okay, fine. Now this is a very homely way of saying things. This is a very homely way of saying things. Like if you want to teach your younger sibling on how to make chai, then you would say like जितना पानी लेना उतना दूध लेना और जितना तुमने पानी लिया उसका डबल तुम चाय पत्ती डाल देना. ठीक? So you will say it like this in a very homely way, but science needs to be concise in terms of how much exactly. So they would say in terms of percentage, right? They would say in terms of percentage. So if I want to make tea, that is chai. If I want to make chai, then I would have this whole chai here. Now in this chai, what do I have? I have 1 cup of H2O. Okay, fine. Then 1. Then I have 2 spoons of tea. Then okay, fine. And 1 cup of milk. 1 cup of milk. That means this is 25% of H2O. Fine. Then I would say 25% of milk. Right? 25% of milk. Then we add in this 2 spoon tea. Okay. Now what you have done here is that you have given a volume. Here this is also a volume. Okay. And you have made a mixture, and by the, if I tell the 25% of H2, that means I'm telling volume by volume. Now if I have 100 ml of tea, I would be having 25 ml of H2O. So science is also like that. They have classified the concentration terms, right? Now we are going to study concentration terms. Now what is concentration terms? What is concentration precisely? Concentration tells us about the amount of solute in. Yes, Ahmed, you were saying something.
When the amount of solute is in more quantity.
In
more quantity.
Then
it is called concentrated.
No.
When no more solute can dissolve in a given solvent, then it is a concentrated mixture.
No, that has some different terms. But concentration, what does concentration means? I mean, see, concentrated solution. But first of all, the concentration is more. You see, if the concentration is more, that means it is a concentrated solution. So first of all, you have to learn what is concentration. Concentration is, it describes the amount of a component in a solution. Okay, you can do this either by telling amount of, can be expressed in different terms, can be expressed in different terms. Acha, one more thing, na, like if you are starting to study something, I mean, let's not keep the baggage of our previous knowledge. Like if you have heard concentrated solution, then that is that. Let us try to learn it from the first principle. Like if you were the first one to study the solution chapter, or you were the first one to study the liquid systems, how would you have studied it? First of all, you would have said, okay, fine, दो component है, they are homogeneous, like they are mixed, and each and every part of them has the same components, 1 and 2, the same ratio. And then, okay, fine, now I have to tell how much component 1 is in how much component 2. Now, component 1 and component 2 are a bit difficult nomenclature of things. So I would say if something is larger amount, that is solvent, fine, one name. If something is in lesser amount, that is solute. So solvent and solute. So how much solute is present in a solvent, I can express in that way, right? So number one expression is amount of solute in solvent, or either I can say amount of solute in solution, or I can say amount of solvent in solution. Okay, or also I can say the ratio of solute and solvent. Okay, I mean, these are the terms, I mean, these are the logical terms by which I can express the different, I mean, express the concentration in different terms, right? Amount of solute and in solvent. Any other terms that you can think of? Like any more way of expressing concentration? No, I guess no. Okay. No, you will have either any of this term, okay? Amount of solute in solvent, amount of solute in solution, amount of solvent in solution, or ratio of solute and solvent. Okay. Now let us look at the concentration terms exactly. What are the terms and how they have expressed it? We can express it in 4 different types of expression. But now number one term here is mass percentage. Mass percentage, which is also given as W by W. W by W. Now, what is mass percentage? Mass percentage of a solution, it is defined as the mass of component of in the solution upon total mass of the solution into 100. Now, mass percentage, you can write it as mass of a component now it is divided by upon
Total mass.
Total mass of the solution.
Mass of the solution, total mass of the solution, or mass of the solution into 100. Now, if I turn to previous slide, that means I have expressed this, I mean this term, amount of solute in solution or amount of solvent or solution, right? This is the two expression in which this particular term is expressed, right? A component means it can either be solvent or solute. So for example, if I have written in Ru Afza 10% W by W. Ru Afza 10% W by W. Now what does that mean? What does that mean? W by W in water. This means that 10 gram of Ru Afza in how many grams of water?
90 gram. 90 gram.
90 grams of water, right? 90 grams of water. Why? Now, see,
Because
if we have this solution, it is 10% W by W. That means the mass of solution is equal to 100 gram mass of Ru Afza pure. This is equal to how much? 10 grams. That is why mass of water will be equal to 100 gram minus 10 grams. That is equal to 90 grams. Okay. No, you can write this down and this down, and then the next slide. Let me know if you're done writing this, okay?
So done.
Done. What about others? No? No. Yeah.
Done, sir.
Nothing. Done. I'm waiting for Mariam and Sanya.
Sir, just a minute.
Okay, fine.
Done, sir.
Yes, sir,
Okay.
done.
I can write it down. I got your message, Sanya.
Sir,
Hmm.
sir, I got
Yes.
disconnected when you were telling this. My phone switched off. Can you explain it?
This mass percentage.
Yeah.
So, I mean, the formula is written up there, but you don't have to worry about the formula because you have to just see how you can use the data. So if somebody says rho of za 10% W by W, that is the expression, that is how we denote the mass percentage. So if it is written 10 W by W in water, it means that there is 10 gram of rho of za in the whole solution. Now, if there is 10 gram, that means the solution is of mass 100 gram, right? The solution will be of mass 100 grams. And then the water will be in 90 grams. The mass of solution will be 100 because it is written 10%. That means 10 upon 100. Now this is rho of za. This is solution. So water H2O will be solution minus rho of za. This is equal to 100 minus 10. That's it.
Okay, sir.
Done. Done. Can we move on?
Yes.
Yes, sir.
Mariam?
Yes, sir.
Okay, fine. So moving on. Now the next thing, Acha, tell me one thing. If you tell 1 spoon of rho of za. Now, what is this? Are you expressing this in terms of volume or
Yes.
mass?
Volume.
Everyone is clear that it is volume.
Yes, sir.
Yes,
right? Because if there is a spoon, it has a definite volume, correct? That it can hold, definite volume, that it can hold the liquid. So if I say 1 spoon, that means it is volume. The next one is similar to mass percentage, that is volume percentage. It is what? Second term is volume percentage. Now this will be denoted by what? Volume by volume. Now just keep in mind that this V and this V, these are in uppercase. These are in uppercase. Okay. Now Mariam or Ahmed, see the Mariam, see the formula for mass percentage and tell me what will be the formula for volume percentage.
1 second.
So volume of
It
component.
will be volume of a compound divided by volume of the solution into 100.
That is not compound, that is component.
Oh, sorry.
Okay, I mean correct that. So that will be volume of a component that is divided by
Volume of a solution.
total volume of
Solution.
and into 100 right? Now
Yes.
the next thing is for example, if I take now, for example, let us take what else do we make? No, what else do we make? Water and milk. 10% milk V by V in water. So amount of milk is equal to 10 gram. Amount of, sorry, not amount, I should write volume of milk is equal to 10 gram. Volume of milk is equal to 10 gram. Now volume of
10 milliliter, right?
right, 10 ml. Now volume of water will be
90 ml.
90.
ml. Then solution will be
100 ml.
100 ml. Easy peasy. Okay. Note this down.
So done.
Done. Mariam done.
Yes, sir. Done.
Shania done. I guess Mariam is also done.
Yes, sir.
Yes. Okay. Now the third one is the mixture of the first two. That is the mixture of first two. So what will be the mixture of first two? Mass by volume percentage. It is mass by volume percentage. How will be this expressed? It is denoted by W upon uppercase V. W upon uppercase V. Now it means that what does it eat? What does that mean? It means that the mass of solute in 100 ml of the solution, in 100 ml of solution, 100 ml of solution, right? And now remember here we cannot do this particular thing that we did the earlier exercise, is that if I have 10% of let us say glucose, W upon V, the only thing that I can say is the mass of glucose is equal to how much? The mass of glucose is equal to 10 grams. Okay. Now the mass of glucose is equal to how much? 10 grams. And then if we have now the volume of the other thing that I can say is that volume of solution is equal to 100 ml. Okay. Now can I say about volume of water?
It will be 90.
9.
It will be 90.
90?
Yes, sir.
We cannot say that, na?
Yes, sir,
Yeah, we
because
can't say
We
that.
cannot say
because
that.
water and volume of water is equal to 1 liter of water is equal to 1 kg. It has been proved that, right?
I mean, yeah, exactly. It is the property of water that 1 ml is equal to 1 gram. That is
Yes,
correct. But we don't know glucose, right? We don't know what will be the effect of glucose when it is added. For example, if I have, let us say 90 ml of H2O, and I add 10 gram, that doesn't mean it will be 100 ml. Right, because the glucose does not have, in glucose we don't have, I mean there is nothing which says that 10 gram of glucose when it is mixed in water it adds 10 ml, right? You see that?
yes, sir.
So we cannot say anything in conformity about the solvent here, right? The mass of solute in 100 ml of solution, we will know only about the glucose, and the volume of solution that will know, that is 100 ml. Okay, and we cannot say about the solvent, which is water. Okay, amount of volume of glucose, I mean you can say IDK. Correct? No, note this down. Cannot be known by the given information. Note this down. Let me know when you're done.
Sir, done.
Okay, done.
Not done.
Oh, not done. I mean, I have to ask Mariam. And Mariam, you try like this particular information that I have given, not 10% of glucose W by V. Then you try
Yes.
to write these 3 terms without seeing the screen.
Yeah, but
Okay,
I injured my hand. That's why I'm writing slow.
you are injured. Oh, I'm sorry. I mean, I am also injured. I can relate it to stuff. There is something in my wrist going on. Is it severe, Mariam?
No, no. Like I was fighting with my brother and then he punched me on my thumb.
Get well soon.
Done, sir.
Done. Okay, fine. And the next term is parts per million. This is the 4th. Why am I writing this? I'm writing this 3, then this will be 4th like this. And this is parts per million. Parts per million. Now you all have mobile, right? Phone in your hand.
Yes, sir.
Can you Google one
Yes,
thing?
sir.
Amount of lead in wall paint. No, or I mean I know about one thing, that is blackboard paint. I know amount of lead in blackboard paint. Can you search that?
Sir, I've joined class through the phone.
Okay, fine. The rest others, if you have some access to other phone or something, then can you look this up? Is anyone looking up?
Yes, sir.
Yes. Okay. %. Achha, Ahmed got okay, fine. I'm sorry. Okay.
So
Did you get that?
last time I texted to the Learnivio, so it did not reach you.
Okay, fine. I got that
Yes.
now. Did somebody was looking up for the lead amount of lead that is permissible in paint? Sorry?
Nothing is
Anybody?
coming.
Paint boxes connect.
I am not able to understand whatever you two are saying now.
Yeah, it's not there. Like the amount of lead, like when we check it up, it's not there. The
It's not there.
specified amount. Yeah, it's mostly like how much
What
is
did
a
you?
chalkboard?
0.1% among all the paint.
It's not-
Like
No,
among
I need.
solution.
Okay, search this 90 ppm of lead. I will get the right results. Now that 1% is not. It is an old data. 90 ppm of lead, and then paint. Did you get anything now?
Sir, it's still showing 90 ppm.
So nothing so far.
Nothing so far. Okay, let me search
It
it out.
says showing why 90 ppm something lead limit.
A lead limit is in there for the for paints, right? So now also you remember about the controversy about Maggie.
Oh
Maggie,
yeah.
they're spelling. What did we find? We found lead. So lead is toxic for us even in very small quantities. Like if we exceeds 90 ppm. Now what is 90 ppm? 90 ppm is 90 parts of lead per million part of the component of solution. Like for example, how do we express ppm? This ppm, parts per million, ppm, it is expressed as parts of, that is parts of component upon total number of parts of all component in solution. Total number of parts of all component in solution. Now you have to multiply this into 10 to the power of 6. Why? Because see, if I had this, only this parts of components upon total number of parts of all component in solution for lead. So what does it say? It says 90 parts upon million. So what is, how many zeros are there in 1 million?
6.
6 0 0 0 2 3 4 5 6. Now this can be written as 9.0 into 10 to the power of minus 5. Right. Now if there is not parts, I could write gram, and this the solution will be also in gram. So it is something like 9.9 into 10 to the power minus 5. But this particular term is not a very good terms for our senses, right? Well, like we cannot understand this term very nicely. Hence, this particular term parts per million was used to express the concentration of solutes which are present in very minute amount. So what do? For example, we had this 9.0 into 10 to the power minus 5. We multiply this by 10 to the power of 6 and we get what? 9. Now this 9, now this, if I multiply 10 to the power 6, I have to also multiply ppm, parts per million. Now this will be equal to 90 ppm, correct? Because this parts per million, it just means that I'm writing 10 to the power of 6 in the denominator. That means I'm multiplying only 1 here, right? This is just a conversion. I've shown 90 ppm into, you have parts of component into 10 to the power of 6. This is used to express solute present in very minute quantity. Used to express the solute that is present in very minute quantity. Okay. Also, I mean, I have to tell you what is toxic. Here's something which is toxic. Anything can be toxic. Okay, what is toxic? Toxic, or what is pollutant? Pollutant, anything which is present in wrong amount in wrong place. Okay, wrong amount and wrong place. Fine. Like water is not considered to be a pollutant or anything which is toxic. But if water goes to your brain, like if you have so much water and you, if it gets in your brain, then that would be harmful, right? So, and of course, like if you have water under your skin also, that becomes a phoda. That is also a pollutant and toxic. So toxic is anything which is present in wrong amount in wrong place. Any hormone, all the hormones that we have, if it is present in wrong place and in larger amount, then it becomes toxic. So there is nothing which is not toxic. Everything is toxic and everything is not toxic. It just depends where it is present and how much it is present. Done? Writing this?
Yes, sir.
Okay. Next thing is mole fraction. Now, mole fraction, I guess you all remember from 11th standard. Yes, no?
No,
Yes.
sir.
Yes, sir, we remember.
You remember? Okay, fine. Do anyone else have a problem in screen sharing that is slow and my voice is lagging?
Yes, sir.
No, okay, fine. Now, is it, what about Amalia and Sanya?
That is clear.
It's clear. Okay, fine, thank God. No problem from my side.
It was lagging.
Okay, fine. It was like at some points. For Ahmed, is it consistent in your case?
No, sir, it was. Now
It
it's
was.
clear.
Now it's clear. Okay. Now, mole fraction. What is mole fraction? It is represented, first of all, it is denoted by how? It is denoted by the letter. What is this letter?
X.
This is not X.
Number of moles.
It is not number of moles. Ahmed, Mariam, what is this?
I don't know. That's either an X or N.
No, it's not an X or an. I'm not doing some tricks here. It is written like this. What about Ahmed? What is this? This is chi. Okay, this is chi. Most probably a Greek or Latin letter. It is chi. Seen as S, like alpha, you have beta, you have gamma. Similarly, you have theta, you have omega, you have chi. Okay, you have chi.
You taught us psi last time.
I didn't taught you psi. I taught you psi like this.
Yeah, you didn't teach chi.
I taught you chi.
No.
So you did.
I did teach you chi, yaar. Like, bhai, ऐसे blame मत करो, please. Mole fraction chi, and I remember to be very much focusing on this term, that this is chi. It is written as chi. It is not chai. It is chi. I remember my words also. Okay, fine. It's chi now. If you remember it as psi, no, this is psi. That is for the amplitude of a wave function. Now this is chi. Okay. Now what is chi? The mole fraction of a component. Mole fraction of a component. Right. Now, if I say of a component, that means both the solute and the solvent can be, or the solute and the solvent both can be expressed using mole fraction. So mole fraction, as the term says, mole ka fraction. So mole fraction, that is mole of number of moles of the component that you want to express in mole fraction upon number of, that is total number of moles, that is fraction, no? Total number of moles. Total number of moles. Now, usually mainly we will deal with binary solutions. Binary solution. Now, what does binary solution means? It means one solvent plus one solute. Okay, that means there is one component which is solvent, one component which is solute. So I will represent solvent as A, solute as B. Okay, so if I have chi A, then I would write it as number of moles of A upon number of moles of, sorry, A plus B or B plus A, anything you can write. So good if I write in a consistent way, that is number of moles of A, number of moles of B. Now what will be chi B? It will be equal to number of moles of B upon number of moles of A plus number of moles of B. Okay. Now the new students, Amalya and Sania, you can write in chat what will be chi A plus chi B. I mean, if it is chat, everyone can write. What will be chi A plus chi B? Sania remembers. Okay. What about Amalya? I guess I am pronouncing her name right. Mariam remembers that. Ahmed, you can do it.
Amalia only.
Amalya only. Oh my
It
God.
will be one.
Are you the representative of Amalya?
No, she's my bestie.
But are you the representative? No. But she has rightly said one. Okay. I guess you all know. Ahmed also answered one, right?
Yes, I was the one who answered through mic.
Through mic, yes.
Yes, sir.
But if you have something that components is large, if we have for solutions with how many, let us say for solutions with, can I take n? If I take n, that would be difficult to express. Let us take j, with j number of component. That means I will say, if I want to, j number of means 1, 2, 3 till j. J is just a number, right? You say na, with n number of things. That is, I'm just taking j because I have to express number of moles in terms of n, and n will look bad. Now this is chi 1. It can be represented as n1 upon n1 plus n2 plus n3 plus dot 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 till nj. Right, this is nothing but the number of components, sorry, number of components and number of moles of first component. Yes, first component. The number of moles, it means n1 upon total number of moles of all component. Okay. Now x2 will be, no, sorry, not x2. This is chi2. This will be equal to n2 upon n1 plus n2 plus dot 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 till nj. Now if I write chi1 plus chi2 plus chi3 plus dot 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 till chi of j, this will be also equal to 1. Correct? Now, you can note this down, note the other one down. Let me know when you're done. Any doubts still here? Anything that you want?
No, sir.
No. Okay. Ahmed, what are you learning in this 12th standard? Python only?
Yes, sir. And we are studying about SQL as well.
SQL also.
Yes, sir.
That's one. In short, like it is a way of making tables.
Yes, sir.
Mhm.
Done, sir.
Fast. Can I move? Others?
Yes, sir, you can.
Yes, sir.
Amalia and Sanya, you all can ask questions. You can ask Mariam and Ahmed. I mean, you can ask any type of question.
Okay, sir.
Okay, don't worry.
Sir, done.
Done. Okay, fine.
Done, sir.
Now, let us do a question. Let us do a question, okay? Now we will use some of the information that we have, like the formula and all. You are asked to calculate. You're asked to calculate the mole fraction of ethylene glycol. Calculate the mole fraction of ethylene glycol. Don't worry, the formula will be given, that is C2H6O2. C2H6O2, ethylene glycol in a solution containing solution containing 10% of C2H6O2 containing 10% of 6,2 by mass. Now calculate this. Do you want me to tell you how to approach this question?
Yes, sir.
No,
Okay,
sir.
fine. Okay, fine. First of all, you have to calculate the mole fraction. Okay, can I have Mariam? She said that yes, I have to
Yes,
explain.
sir.
So first of all, you have the mass percentage of ethylene glycol, right? That
Yeah.
is 10%. Okay, fine. That means if you move on, right? If you are writing, just pause a bit. This here, you have this statement written. That means you know these three statements,
Yeah.
right? Okay, fine. Now, if you know these three statements, you know the masses of all of them: solvent, solute. You will be knowing the mass of solvent. First of all, let's write solute and solvent. Okay. Now, there are only two components, solute and solvent, right? What is the solvent?
Yeah. Water.
There is no written water. So first of all, you have to ask what is the solvent. Okay. You have to calculate the mole fraction
Okay.
of dilute glycol in a aqueous. Now, if I write aqueous solution in an aqueous solution. Okay. If I write aqueous solution, that means it is the solution. The solvent is H2O, right? And the solute is C2H6O2. You know the mass of solvent. You know the mass of solute. Now you will find the number of moles. You can find number of moles from the mass. Yes, Mariam?
Yes, sir. Given mass by molar mass.
Given mass by molar mass. And then if you have number of moles of both the solvent and solute, that is this, you have number of moles of A. This is solute, so this will be B. Number of moles of A. You have both number of moles of A and B, and you can apply this and find mole fraction. I hope it is clear for Amali and Sanya also.
Yes, sir.
Yes, sir.
Let me know if you're stuck somewhere. I hope you all got this as the molar mass of ethylene glycol.
Yes, sir.
Acha, fine. Yes, Sanya. I think that's not correct. Something in decimals, I guess. I mean, no. See, Sanya, you can confirm the answer by checking this. Is chi A plus chi B equal to 1? Then it's right. If not, then you have to reconsider your answer, reevaluate where you have done right, wrong. Okay, Ahmed has left.
Okay, sir.
Sir, I got 68. I mean, in the molar mass.
Molar mass, how? 12 into 2 plus 6, that is for hydrogen. The molar mass of carbon is 12. Hydrogen is 1. Oxygen is 16. Where did you went wrong? I guess in hydrogen?
No, sir. I wrote 6 into 1.
Okay, fine. So you have 12 into 2, that is equal to 24. 6 into 1, that is equal to 6. And 16 into 2. Do you write this as 18 or something? No, that would not be.
No, I wrote a 16 itself.
And then how did you get 68? Simple addition, no? 24 plus 6, 32. 24 plus 6 will be equal to 30, right? Let us do this first. 24 plus 6 is equal to 30 plus 32. That is equal to 62. No, yes.
Yes, sir. Sorry.
Okay, fine. Sanya, any you got the any other answer that you got? No, yes.
Yes, sir. Yes, sir. I got for X. I got 0.068.
Okay, fine. We will look. I mean, I don't know the answer. Let us calculate it now. C2H6O2. Now, what will the number of moles? Moles of C2H6O2, that will be equal to 10 grams, right? 10 grams upon 62 grams per mole. Okay, per mole inverse. So the first thing that I say is you have to eliminate the units first, gram and gram. You cut these off, then you see, okay, fine. What is the unit? Mole inverse, and it will go up and it will form mole. So mole is in terms of in units of mole. That means we are heading in the right direction. Now you have 10 upon 62. 10 upon 62 mole. Now this will be equal to how much? Did anyone calculate?
0.1.
0.161.
Yeah,
161.
Yes.
0.161. Okay, fine. Now I guess that is right. Number of moles of water. Water is equal to, what is the number of moles of water in? Right. Okay, fine. I guess all of them you got this right. 90
Yes,
upon
sir.
Yes, sir.
18 grams
mole.
per mole. This gram and gram will be cancelled. Now this will be how much?
5.
First
5.
5.
Yes, sir.
5 mole. 5 mole. This is 0.161. This is mole. Now it is easy. Now we want to determine what is chi A. No, sorry. Let us find chi B because that has been asked. Chi B is equal to number of moles of A, right?
Yes, sir.
Yes,
And the
sir.
number of moles of B,
No,
not A.
B.
Sir,
B.
chi
And
B
that's
is ethyl. I mean ethylene glycol.
Yes, chi B is ethylene glycol.
Okay.
This is our B. Water is A. Okay. And then this will be how much? 0.161 upon 5 plus 0.161. This is 0.161 upon 5.161. Now also remember, if I put the units here, this is mole. This both addition is also in mole. This mole and mole will get cancelled, and the mole fraction is unitless. So did anyone get the answer? What is the answer?
and 0.0311.
This is equal to, let me check, 0.161 upon 5.161. It is 0.0311.
Yes, sir.
9. Okay. Now what will be chi A?
1 minus 0.03119.
0.03119. This is the better way to do it. Avoid calculations. Now what will be this much?
Sir,
Yes.
sir, how to divide that to 0.161 and 5.161?
Really?
Yeah.
Okay. How to divide that? Okay, fine. Let us tell this much. How much is this? This will be around 0.96. How much? 0.96?
8.
8. Then
So I don't know after that.
0.968. That means 0.968. Then this should be again 8, and this should be 1. 8, 0.96, 0.9688. This should be 1. Now it is right. If I add 3,
So is
1,
it okay if
9,
we
0, 1,
is it okay if we divide 5 by 5.161?
I mean, it is fine. I'm just seeing is it right or not. Okay, this is the answer. Now going to Mariam's question. You can write up till 2 decimal points. Okay, 2 decimal points. After decimal point, 2 non-zero numbers. 2 non-zero numbers after decimal point. That much preciseness is okay in your standard, in your class. How to divide 0.161? Can someone pitch in here? Can someone tell how to divide this number? Anyone know? Ahmed is saying something. Oh, first of all, do this 10 to 10 and how many zeros? 10, 2, 3 upon 1, 2, 3. Okay. Now you get how much? This is 161 upon 5161. Correct. Now how to divide this also? You want to simplify it more. This is smaller number. This is larger number. Then I mean what I'm teaching now. If you multiply this by 100 and this by 100, then also no changes there. But you will write this as 16100 upon 5161 into 100. Okay. Now what you have to do, you have to divide this term, and whatever the answer you get, you just divide that answer. You can answer whatever answer you get upon 100. That means 2 decimal points. You have to place it in the left leftward direction. How to divide this? 5161 upon 16100. Now can you divide this, Mariam?
Yes, sir.
Fine. Okay.
Okay.
So you all got the answer right. Okay. Now let us turn to next concentration terms. How many concentration terms did we do? I guess we did 5. Now the sixth one.
Yes, sir.
Sixth one is molarity. Familiar term?
Yes,
right?
sir.
It's familiar. What is it? It is denoted by capital M. It is denoted by capital M. Now somebody please pitch in to tell the definition. Ahmed, tell.
We have to divide this by volume.
Number of moles of
solute.
Solute dissolved in dissolved in
number of volume.
Number of volume, no, volume of dissolved in
Volume.
In volume of in
1 liter of solution.
And this has to be defined in 1 liter of solution. What is the volume that is defined? 1 liter of solution. Now you will express this molarity is equal to number of moles of solute. That is moles of solute upon volume of solution, that is represented in liters. Okay, so you will write it like this: number of moles of solute, that is NB upon volume in liters. Volume in liters. Okay, fine. Now what will be the unit of this molarity? And this number of moles is written in mole upon, this will be in liters. Mole per liter or mole liter inverse. Mole liter inverse. Okay. Fine. What do we have here? Do we have volume here? Volume? No, you don't have volume here, right? So let us do another question. Start writing this down till the time I'm writing the question. Okay.
Okay, sir.
Solution containing 10 gram of NaOH in 10 grams of NaOH in 900 ml of solution. 900 ml of solution. Calculate the molarity of the solution containing 10 gram of NaOH, sodium hydroxide, in 900 ml of solution. So remember one thing, that it doesn't matter if you have been given this, what is the solvent. You don't need solvent in this particular concentration term, that is molarity. Okay. You just want to know the number of moles of solute and the volume of solution. Now you will first of all in chat tell me what is the molar mass of NaOH? That you found. Then you will tell me number of moles of NaOH that you found. Moles of NaOH. How much you got that? Okay. Yes, correct, Maria. Okay. Huh? Maria, if you don't know, then calculate.
Okay, sir.
Moles of NaOH. Then you will let me know about the molarity. Mm. 0.25.
No, sir, it's 25.
25.
Yes, sir. 1 by
What is
4. 25 percentage.
Percentage? I'm not asking percentage anywhere. No, Mariam, it's not. So it's a sodium. No. Oh my God.
25 moles of NaOH.
No.
No, sir.
No. What is the, how much gram of NaOH is present?
10 gram.
10 gram.
10 by
Then?
4.
And what is the molar mass? What is the molar mass of oxygen?
16.
16 plus hydrogen.
1.
1.
1.
23.
Plus 23. 23
That
is
will
for sodium. Okay.
Yes, sir.
I'm not seeing number of moles. Whatever you are saying, that is wrong, Mariam. I don't know what you said, but I don't think any answer is. You gave something like 35.5. No, 35.5 is here. So this will be equal to 40. Number of moles, 10 upon 40, right? And this is gram per mole. And this will be number of moles will be in number of mole. How much will be this? 10 upon 40 fast.
0.2.
0.25. So what were you saying about percentage, Ahmed?
So I was actually saying 0.25 moles.
Moles. Okay, now molarity will be?
It will be 0.25
0.25 by 900.
0.9.
0.25.
0.9. Why? Volume. What is the volume? Volume of
In
solution
liters.
in
Yeah.
liters. That is equal to 900 into what is milli? 10 to the power minus 3 and liter. Okay. So this will be
Yes.
equal to how much? 0.9 liters. Okay, 0.9 liters. So molarity
2.77777.
okay, so I mean this will be equal to 0.25 upon moles upon 0.9. 9 liters. That is equal to how much you said? 0.27777. You can round it out to 8.
2.7 or 0.27. Yes, sir.
Yeah, 0. We can round it off to 278. Okay. Also, now this liter is also sometimes known as dm cube. That is decimeter cube. Okay, what is dm? Dm is decimeter cube.
Decimeter cube.
Okay. So you can also express that as like this: 0.278 into not into mole dm cube, mole per dm cube. Now, why do we prefer this dm? Chemists and scientists, they prefer dm instead of liter, ml, etc. Why is that? Because liter and ml, these are derived units. Okay. Now this length is a basic SI unit. Okay, this is the basic, one of the basic SI units. Like, and length into length, this is area. So area is derived from length only. Area is derived from length only. Similarly, the units of volume we have, if it is milliliter or liter, it is derived units, and this dm is the most basic and the first unit of volume of area also. Okay.
Yes.
So that is why you will see sometimes dm cube written. Now we have done how many? Molarity. Now what remains?
Molality.
Molality.
How many of you remember the formula for molality?
Me.
Tell me.
It's
Molality.
divided by kilogram.
Yes, sir. 1 kilogram
Moles of solute
upon mass of 1 kilogram. Mass
upon
in
mass
1
of,
kg.
mass of what? But solvent, solute, what?
Solution.
Mass of solution.
Mass of solvent.
Oh,
Mass of solvent in kg. Okay, mass of solvent in kg. So I will write this as what? This will be written as NB upon W of A in kg. This is what? Molality. See, and it is denoted by lowercase m. It is denoted by lowercase m. It is the number of moles of solute dissolved in
1 kg
1
of solvent.
kg of solvent. 1 kg of solvent. Okay. Now let us look at some of the concentration terms that we have seen. Concentration terms involving volume, and I will write the others involve no volume, in which there is no volume. Okay. So first one is that we have seen just now. It is molality. It does not have volume component in it. Molality. And why I'm defining it and why I'm separating these terms, I will let you know, and you will also come to know. See, molality does not have any volume element in its formula. Okay, what about the? Now tell me from here only. Molarity. It does have volume. It has a volume component. Molarity. Now previous, let us go to mole fraction. Does it have any volume component, volume element in the formula?
A volume percentage.
yeah.
No, mole fraction. Mole fraction does not have. So mole fraction. I am writing this as chi. You will remember it. Okay.
Yes, sir.
Chi. That is mole fraction. Now, what was the previous one? Parts per million.
Parts
correct?
per million.
Now the parts ppm, it can be expressed in mass also and in volume also. Like if you have the parts as mass, then it is mass. If it is volume, then it will be in volume. So I'm not writing this in any category. It can be any of them. Okay. So what is the next one? Previous one, I guess.
Mass by volume.
Mass by volume. So mass by volume, it has a volume component. This is W by V. The next one is obviously V by
Volume
V,
percentage.
and this one is M by M.
Mass
No, not M by M, sorry, W by W. W by W. Okay. Now, why have we divided in terms of which contains volume and which does not? It is only because the concentration terms that have volume element in it, are temperature dependent. Why? What do you think about the volume? What happens if we increase the temperature?
It evaporates.
Volume is directly proportional to
Temperature.
temperature. Right? So since as volume is directly proportional to temperature. Okay. Now I guess you have to write the molality. Yes, write this molality.
Done, sir.
So done.
Yes, I'm done.
Now I can write these are temperature dependent. Okay, and these ones are temperature independent. How many classes have you done in school?
We started school on 14th.
14th of March. So I guess
Yes.
how many classes are 4, 5? Where are you in school? This chapter. Is this chapter done?
No,
sir.
not yet done.
Then
We finished 1 or 2 laws.
Like
okay, Henry law and Rawls law.
Yeah.
Rawls law. Okay, fine. So what is left? Okay. I guess in this year also the same pattern will be followed, which was followed the last year, because it's not offline yet, right?
Yes, sir. But they are saying in September they will open school.
In September, they know what is going to happen in September. Okay, fine. We'll see.
I don't know. They are saying
Ah,
our ministry gave permission already, but they are not opening.
the government school over here are open already, and some other schools as well. Like they are allowing the school to open, but they must take the precautions.
They must take the precautions. And also, is it like all you have to call 50% of the whole population? That also no.
We don't know.
No, sir,
exactly.
we don't know about that yet.
I mean,
They
I guess
did not mention that.
Achha.
But before it was like that. Only one student had 3 classes in a week.
Achha, in a week, 3 days. He has to go 3 days. Okay.
Yes, sir.
Here also some 11th, I guess 9th, no, 10th and 12th standard students are allowed to go to school, but alternate days, I guess. Only 50% of the attendance are allowed to. It's like this.
Sir, done.
Yes,
Yes,
sir.
sir,
Two
done.
questions. Okay. Am I clear? Is my voice clear?
Yes,
Yes,
sir.
Yes, sir.
You have to calculate the, let us see, the calculate molarity of the following. Let's do molarity first. Molarity of the following. Okay. Now, if you have, what do I have to give? I have to give either the number of moles, or I have to give the mass of. I have to give the mass of a mass of the solute, and I have to give what? I have to give the solution. I have to give the solution. Okay. Let us take 30 gram of cobalt nitrate. What is cobalt nitrate? CON3 dot 6H2O. Okay, this is the solute in, and let us take 8.6 liter of solution. Do I have to give you what is the solvent?
No.
No, right? Yeah, I don't have to give you. Okay. The second question is, now what is there? You have, for example, let us take 60 ml. You have 60 ml of 0.5 molar H2SO4. Okay. You have 60 ml of 0.5 molar. So you have the solution, the amount of solution, that is 60 ml, and the concentration of solution is given 0.5 mole, and it is diluted to 500 ml. It is diluted to 500 ml. That means, first of all, you had 60 ml of the solution. Okay. Now you added some water, or any solvent, and you made the solution out of 250 ml, 500 ml. Sorry. Diluted to 500 ml. Okay. Now, do these two. Let me write the third question. Okay. With the first one, it is a bit easy. Second one involves some conversions.
So, what is the molar mass of cobalt?
What is the molar mass of
Cobalt.
cobalt? Is in which group? Where do you see? I mean, in which block? First of all, tell me.
I forgot.
Huh? Don't know.
I forgot. Yes, sir.
It is in D block. If you remember, Sakti Vikraman, Fico, Nikuzan. Remember that? Sakti Vikraman, Fico, Nikuzan?
No, sir.
No, no, you don't remember that. Okay, fine. It's 58.9. You can take it as 59. Okay.
Yes, sir.
calculate these three, then we will move to next type of questions.
Sir,
Hmm?
how much is the molar mass for that CONO3.6H2O?
CONO3. Oh, just wait a second. I have written NO3 like this. Oh, wait a second. I'm really sorry. This should be NO3 twice. Make that correction. NO3 twice. You have to make few adjustments. Okay, fine. You have NO3. You have done 3. So you have to remove the nitrogens. CO is how much? CO is 59 plus.
Yes.
What do we have? Nitrogen. The molar mass of nitrogen is 14 into
14.
you have twice of nitrogen plus you have oxygen. How much? 16. You have 3 into 2 because 3 oxygen and then twice of it. Plus you will be having the next one is what? 6. H2O. H2O is how much? 1 into 2 into 6. Correct?
Yeah.
Or I can write it like this. Can you write it like this? H2 is 18, so 6 into 18.
Yes, sir.
So you got all these terms correct?
Yes.
Everyone?
Yes,
Saya also? Okay, fine. Then you will get the answer right. How much is this? How much did you get? This one.
I didn't get.
Let's calculate this now. 30 gram of cobalt nitrates, UNO3 twice, not 6H2. This is 59 plus 28 plus what is 16 threes are? What is 16 threes are?
16. So in total that will be 96.
48.
48 twice of 48 is 96.
Yes, sir.
Plus what is 18 6 are?
108.
108. 90 plus 18. Now this is 60, this is 27. 60 plus 27 is equal to 60 plus 27 is equal to how much? 60 plus 27 is equal to 87 plus 96 plus 108. Now this is what? This is 100 plus, this is 100 plus how much? This is 100 plus 83. This is equal to 183 plus 108. Correct? Now this is equal to how much? This is equal to 191 plus 100. This is equal to 291 gram per mole. Correct?
Yes, sir.
I know. Now move on in 8.6 liter of solution. Oh, sorry. First, you have to calculate the molar mass. Now you have to calculate the molar mass. Now you have to calculate number of moles. Number of moles. This will be equal to how much? It's 30 gram upon 291 gram per mole. This will be equal to
0.103 mole.
0.103 mole.
Yes, sir.
Did other get it somewhat like this? That
Yes,
is C. 30 by 291. That will be equal to 3 tens are, and this will go upon 9 nines are and 7. 97. 10 upon 97. I have to divide that. 10 upon 97, this will be equal to 0.103. 0, fine, it is 0. Then ones are, then I will get 97 because of 100, then I will get 3. Then I will have to put a 0, then this will be, okay, yes, it's correct. 103, then other numbers will also come. 103, then I have to put again a 0. Mariam, got this?
Yes, sir.
Now next, what do you have to do? Molarity. Answer आ गया क्या किसी का? If answer has come, तो आप बता दो. 0.103 upon 8.6. This is mole. What is the answer? Anyone? No. Yes.
0.011.
0.011.
0.011. Mole liter inverse. Yes, sir.
Any other terms? I mean, is it terminating or do you have any other term here after 0.11?
9 is there.
9 is there, na? Okay, fine. If 9 is there, then we have to get what? 1, 2.
1, 2.
Mole liter inverse. Correct, Ahmed? If 9
Yes,
is there, then you have to round it off to 2. And if it was below 5, then you have to round it off to 0.11. Okay, got this. Now the next one. Okay, please, one thing. You don't have to use like this 9 plus 8. 8 plus 9, this will be equal to how much? 7, then 87. Don't do additions like this. You just think of this 59 as 60, this 28 as 27. So what did you do? From 28 to 1, you gave 1 to 59. This is 60 plus 27. It is easy to calculate in this way, okay?
Yes, sir. So I add all the even numbers first and then I come to.
That is also good. Add the even numbers, then come to the odd number. Next one, 60. Can I erase this?
Yes, sir.
Yes, sir.
This question here, it is given that 60 ml of 0.5 molar H2SO4. So I have in this, this is 60 ml. And in this, I have 0.5 molar H2SO4. H2SO4. If I write the formula, then I will get 0.5 molar is equal to the volume of solution is how much? The volume of solution is constant. What is it? 60 ml. That means it is equal to 0.06 liters. Correct?
Yes, sir.
And this will be number of moles of H2SO4 that I have to find. Because if I am diluting it, so what is remaining constant that I have to look, right? See, if I am diluting this 5 should be here only. If I am diluting this, add water, add H2O or anything else, then what is going to happen? I will be having the volume of solution will change. Okay, volume solution will change. If the volume changes, that means concentration changes. But what is constant? Amount of H2SO4 is constant, right? Because we have added water, we have removed H2SO4, neither we have added H2SO4. So the amount of H2SO4 is constant. Correct?
Yes, sir.
So I can write it like this. Number of moles of H2SO4 initial is equal to number of moles of H2SO4 final. What is the number of moles of H2SO4 initially? The number of moles of H2SO4 initially, you can find it here. And the number of moles of H2SO4, I mean, whatever you get answer here, this will be equal to how much? And H2SO4 will be equal to 0.5. What is molarity? It is nothing but mole liter inverse into 0.06 liters. Now this liter inverse and liter will cancel each other. What will be the answer now? 0.030. 0.030. 6 5s are 30. And you have 3 decimal point 0.030 moles. Now this 0.030 moles, this will be equal to number of moles of final. Now this can be expressed as concentration, that is molarity, into volume. That is the final volume. This is volume final, correct? Now this is molarity final. I can write molarity final is equal to how much? It is equal to 500. So 0.030 upon 500 ml. It can be written as 0.030 upon 0.5 liters. Now this way we will get a molarity final. Did you get the answer? Oh, fine. Did you get the answer? Yes.
Zero 0.06.
0.06.
Yes, sir. 0.06.
0.06 what?
Mass.
Mole per liter, that is molarity. Okay.
Yeah.
So from here I can from here you can say one more thing, that in dilution, happens moles or initially it is equal to number of moles final. What is number of moles initial? It is initial M1 V1 will be equal to M2 V2, correct? M2 V2. Okay, this is the formula that you can use. Now do the next one. Let me know the answer. .98 gram of H2SO4 in 500 ml of solution. What is the molar mass of sulfur? Molar mass of sulfur is equal to 32 grams per mole. .98 gram of H2SO4 in 500 ml of solution.
So that will be 1 mole.
That will be 1 mole?
Yes, sir. Okay. 98 by 98.
Yeah.
Yeah, sir.
So what is the answer?
1 mole by 0.5 liters.
So what is the concentration?
0.5. I guess.
Do it.
So it will be 2.
2 mole per liter.
Yeah.
Mariam?
2, yeah.
Do it.
2 mole per liter.
2 mole per liter. This was easy, quite easy. 98 gram H2SO4 is equal to 1 mole, and we have molarity is equal to 1 mole upon 0.5 liters. This is equal to 1 upon 1 by 2. This is equal to 2 moles per liter. Okay. Now, next question. And okay, I am done with the slides. I guess I have to erase this. I've ended 20 slides. Okay. The next question in this, you have to calculate. You have the molality given. Okay. You have the molality given, and you have to find the mass of how much urea is required. You are given molality. Molality is equal to 0.25 is equal to 0.25. Okay, 0.25, and it is required. How much is required? Mass of urea. You have to find mass of urea. Mass of urea. You have to find mass of urea. Okay, this is the question. The question is calculate mass of urea. Calculate mass of urea. Required to prepare 2.5 kg. 2.5 kg of, you have to prepare 2.5 kg of 0.25 molar solution. Okay, so you have been given the molality, you have been given the mass. You have to find the mass of urea that is required. Okay, so anything else that you need here?
It's a formula for urea.
Okay, formula for urea is NH2 CO NH2 is like this: NH2 C double bond O NH2.
Sir, Sir, Sania is in the waiting room.
I just started her.
Okay.
Just giving you a hint, you have to go in the reverse order now. You have to prepare 2.5 kg of, you have to prepare 2.5 kg of 0.25 molar aqueous solution. You have been given the mass of solution here. Okay, you have been given mass of solution, and you have been given here molal. So you have to check, you have to also determine the mass of solution and the solvent. Sorry, solvent. You have been given the mass of solution, you have to determine the mass of solvent also. If you are stuck, let me know. Okay, if you are stuck, let me know. If you are stuck, let me know. Urea.
The molar mass of urea is 60.
NH2 14. Then 16 CO. Yes. It is 16 plus. Sorry.
I forgot to add 14.
You forgot to add what?
Nothing, sir. I got it.
Got it? Okay, fine. Nitrogen 14 plus 16 into 2. I can write 16 into 3 plus 12. 16 into 3 plus 12. 116 for NH2, 116 for NH2, 116 for oxygen. So it'll be giving 60 gram per mole. Okay.
Yes, sir.
Sir,
Hmm.
we have to convert kilogram into gram.
You tell me, do you have to?
Yeah, do we have to? Okay.
I'm asking you, what do you think? You see the formula for molarity? You have to convert grams into which grams? Kilogram, this kilogram into grams? I don't think so. I don't think so. Why do you think you have to convert that kilogram into gram?
Because it's molarity.
So in molality, you have kilogram in the formula, no? No, yes, you have kilogram in the formula. I mean, you can
So we have to find the mass of solute, right?
Yes, you have to calculate the mass of urea that is required. Yes, you have to calculate the mass of urea solute. Mm, 37.5 grams or something else.
Gram.
Gram. Okay, we will see. And we will see. I haven't calculated yet. We will see. Should I start? What is given to me is 0.25. I have to make 2.5 kg of 0.25 molar solution of urea. Okay. Okay. That means if I have 0.25 molar solution. 0.25 molar solution of urea. That means what? It means that I have 0.25 moles and 0.25 moles, and I have how much? I have 1000 grams of solvent. Right? Up till here, anyone has any doubt? If I have 0.25 molar solution, that means in every 1000 gram, I have 0.25 moles.
Yes.
Ahmed, your voice was not clear. Can you repeat that? Okay, fine. 0.25 molar solution has 0.25 gram. That means mass and solution will be how much? Mass of solution will be mass of solvent. Okay, I voice cracked in between. Repeating it again, mass of solution here will be
still the same.
The mass that is 0.25. No, it will be number of moles into molar mass, correct? Right, because what is molar mass? That is given mass upon, sorry, what is number of moles? What is number of moles? Number of moles is equal to how much? Number of moles is equal to given mass by molar mass. So that will imply W is equal to number of moles into molar mass. plus mass of solvent. How much is mass of solvent? That is 1000 gram. This will be equal to 0.25 into 60 plus 1000. That will give me how much? 0.25 into 60. How much is that?
15.
0.25. It is equal to 15. Correct?
1500.
Not 15. It is just 15 grams.
Okay.
Plus
Okay.
1000 grams. This will be equal to 1015 grams. Any doubt here, Sania, Mariam, Amalia?
No, sir.
Okay, fine. See, I have to find the mass of solution, right? I have found the mass of solution. Okay. Now that means it means that okay, I have to again go back and I have to clear this. Okay. It means that I have this much mass of solution, and if I have 1015 gram of solution, I need how much? I need 60 gram of urea. 60 gram of urea is required to make 1015 gram of how much molar? How much molar? 0.25 molar. 0.25 molar. 0.25 molar solution. Correct?
Yes, sir.
So 60 gram of urea is required to make 10-15 gram of 0.25 molar solution. And how much I have to make? I have to make how much solution? Now this, tell me fast.
2.5
please.
kg.
Oh. It's not 60, it is 15 gram. Remember, this is number of moles, this mass of urea is how much? 15, na? Not 60. You see that?
Yes, sir.
15 gram of urea is required to make 1 point itna molar solution. So requires 15 gram. 1 gram will require 15 gram, 1015. So 2500 grams will require how much? 15 upon 1015 into 2500 grams. Calculate this and tell me how much is this. You got this as 37.5, all of you?
So I did it other way.
I guess you didn't add this mass of urea in solution, correct? Mariam and Ahmed?
Yes, I don't know.
You don't know?
I did mass of this molar.
Sir, I just used the formula. I did
Molarity
0.25 is equal to x by 60 divided by 2.5.
Yes, I did the same way.
And
then I just
you have
shifted
to remember
50.
na, this molality is equal to number of moles of solute upon, this is the mass of what? This is the mass of solvent. And what you have been given is the mass of solution, na? 2.5 kg molar solution. The 2.5 kg is the mass of solution, right?
Oh, yes, sir.
So first of all, you have to find in 0.25 moles, if you have 0.25 molar solution, how much urea is required for that and what is the mass of that solution. Okay. Then what do? You just do unitary method. Should I repeat it?
Yes, sir.
Okay, fine. I'm just clearing this one now. See, you had been given what? You had been given 0.25 molar solution, and you have to make 0.25 molar solution. How much? You have to make 2.5 kg of itna. 2.5 kg of 0.25 molar solution. Okay. So, and you have to how much urea is required. How much urea is required? So what you will do? You have been given molal. So if you have what is molal, m is equal to moles, the mass of solvent in kg, right? So if this was solution, then it would have been very easy. You would have directly substituted 2.5, correct? But here, what is the formula? You have the amount of solvent in 0.25. You don't have the amount of solution. You have to find how much urea is required. How much you have been given? How much urea in 1000 gram? You have this information, right, Mariam? How much urea is required in 1000 grams, correct? This is how much you have been given. This is you required how much urea you required how much?
2.5. Huh?
Did I mess up?
So we have to find the mass of urea.
For mass, but you have to start with molality, na? You have to find the number of moles first.
Yeah. Molality is given as 0.25.
The molality, the number of moles required is 0.25 moles.
Yes.
In 1 kg. Okay. In 1 kg of what? Solvent. But I have to find how much moles of urea is required in 1 kg of solution first, because I have to prepare 2.5 kg of solution. I don't want to know in 2.5 kg of solvent how much it is required. I want to know how much is required in 2.5 kg of solution. So first I have to write this particular concentration terms in terms of solution. Fine. So 0.25 moles in 1 kg of solvent. That means that mass of solvent is given how much? 1000 grams.
1000 grams.
Mass of solute is how much? 0.25 into 60. That is equal to
30 grams.
No.
15
grams. Correct. So mass of solution will be how much?
1015 grams.
1015 grams.
Gram.
Okay. Now we have each and every terms. Like if now I know everything about this particular concentration, I know that if I want to tell it in terms of solvent, then I will say that 15 grams is required, can be mixed in 1000 gram of solvent to get 1015 gram of solution. Okay. Now I can play around with this information. Now I can play around with this information. How? What we want to know? I want to know how much in
We need
2500 grams. How much in 2500 grams? So in 1015 grams, I need 15 grams, right? So in 1 grams, I will be needing 15 grams upon 1015.
1015.
Then 2500 grams, I will be needing how much? 15 upon
1015 into
2500. Fine. So this one, if you calculate it, it will be around 37. It will be around 37 grams.
Yeah.
Okay. Amalia and Sania, did you get it?
Yes, sir.
Yes, sir.
Okay. So the important thing was it was given 2.5 kg molar solution. Now this was the tricky part. It was given solution. Okay. Note this down. Noted this down. Can I move to the next question?
Yes, sir.
Okay. Now wait a second. I can erase these now. Okay, I can erase this. The next question is again You have to be very careful while doing this question. You have to calculate everything. I mean everything. By everything I mean you have to calculate molality. Then you have to calculate molarity. Then you have to calculate the mole fraction. Oh, listen. I'm really sorry. It's already 10 now.
Yes, sir.
Arey.
For us, it's 7:30. 30 minutes.
It was sorry. It is almost 8, right?
Yes.
Remind me. I was thinking. I would have taken this till. I mean, it's 7:30 now. I would have taken till 8, I guess, because I was thinking, okay, fine. I have to teach from 6 to 8. But now the timing has been changed. I'm really sorry. We will do this question in the next time. Okay.
Yes,
Remind me next time.
So I thought of reminding, but later I was like, maybe you will say I want to run out of this class. So I was like, let